My novel research presentation is on the ethical implications of cybersecurity threats in robotics. So just a brief introduction. I know that we're all familiar with robotics, but it is a field of engineering focusing on the design, construction, operation, and maintenance of intelligent machines called robots. There is the sense, think, act paradigm, which allows robots to obtain information about their environment with various sensors such as cameras, lidars, radars, and then make decisions with that data and eventually execute tasks using their actuators. All of these systems are, however, vulnerable to kind of a wide range of security attacks that can compromise many aspects of their functionality, safety, and reliability. So moving into some of the actual examples of attacks that can be made on the sensor suite of many robots. These sorts of attacks aim to manipulate or damage hardware so that its output is corrupted or some sort of unauthorized access is granted to a user that does not have the correct privileges. The targets of these attacks would be the sensors, like I mentioned earlier, GPS receivers, LiDAR, radar, cameras, and things like that. A lot of these sensors are sensitive to jamming attacks, which can lead to a deterioration in the quality of the captured data. And then these sensors are also vulnerable to spoofing attacks, where false information is sent to the device. And you can see a depiction of that in the figure on this slide, where the vehicle is being sent false GPS data from the person on the side of the road, causing their trajectory to change from where they actually want to go to where the spoofed signal is telling them to go. Now moving to the actuators on the robots. So these actuators are the devices such as joint manipulators, wheels, and propellers that enable the motion of the robot. And like the sensors, the attack surfaces for actuators are kind of wide-ranging. They can include the physical hardware, the firmware that's installed on them, the communication protocols that they follow for exchanging data between the actuators, sensors, and other computers on board, and then the network components themselves. There's several examples, but one would be hardware level backdoors that essentially can allow an attacker, hacker to bypass the robot's control protection mechanisms and remotely control a system. A lot of the things that I've been reading for vulnerabilities in robots can be related to unsecured firmware downloads or unsecured communication across the internet, and then sort of weak or no encryption being used can, once again allow an eavesdropper to listen in on the packets that are being sent back and forth, gain credential information, or learn about the messages that are being sent to be able to replicate them. Now moving into some of the state-of-the-art defenses for these sorts of cybersecurity attacks on sensors and then the actuators. There's several novel methods that I've read through that enable to protect sensors from hacking. In terms of cameras and lidars, I've seen some certain kinds of light able to be filtered out using these photochromic lenses. And this is allowing these sensors to not be jammed by a blinding light source, which is kind of a common way to um, cause the camera data and LiDAR data to basically become unusable. Techniques such as data filtering, randomization, and fusion can be used to enhance the robustness of GPS receivers. This is to fight the spoofing attacks that will cause the receivers to uh, be getting data from some other bad actor that is sending fake data their way. And then an example on the right can be seen that is showing and one example of the sorts of advances in machine learning that have enabled the sort of improved methods for detection of GPS spoofing. And here, this is kind of an encoder and decoder network that's being used to be able to sense if the sensor data or the GPS data is in fact valid or not. And this one was actually pretty successful. It was able to detect attacks basically within 3.3 seconds. And I think it was about 60 out of 80 times it was correct in detecting spoof data. So there are some um, sort of impressive improvements in using machine learning to be able to combat GPS spoofing. Now to the state-of-the-art defenses for actuator attacks. The figure below shows a controller that basically allows for dynamic filtering of control signals that are being received by the actuators to protect against adversarial inputs, basically figuring out if the inputs that they're receiving are in fact valid. This is a relatively simple fix, but access control mechanisms need to be implemented to, ensure that verified programs are able to send control signals to the actuators, as opposed to any sort of program that could be installed by a hacker. Anomaly detection systems have also been developed to monitor and track anomalies during a robot's tasking, specifically the commands that are being sent to the actuators. And then kind of another simple one, but not as frequently used as you would think, ensuring that secure communication protocols and encryption is employed between robotic components. So with the sorts of attacks described and some novel methods for combating these attacks, um, I think it brings up some important ethical questions. Robotics does have the potential to make a very large positive impact in many sectors. I mentioned healthcare, transportation, industrial exploration, but there are, many more that robotics has the potential for improving. Um, but with the sort of wide-ranging ways that robotics technology can be hacked and misused, I think some important questions need to be addressed when developing the technology. So given the significant benefits that technology offers, how can we balance the deployment of these technologies against the risks that they pose, especially considering the possibility of cyber attacks that could lead to substantial harm to humans? And then, you know, while considering these cybersecurity threats, how can we determine if a technology is secure enough to be introduced to the public, ensuring it has, adequate defenses against hacking and unauthorized access? So moving to the lit review section, the first sector that I looked at was the intelligent transportation systems. And this is basically vehicles and infrastructure communicating with each other, cooperatively sending and receiving information such as a vehicle's speed, acceleration, heading, a desired, path that it wants to travel on. and then also exchanging information with roadside infrastructure and vulnerable road users such as pedestrians and bicyclists. This communication is enabled by the 5.9 gigahertz radio frequency band, and kind of like some of the um, vulnerabilities that I mentioned earlier, this band is especially vulnerable to congestion and jamming attacks that could result in denial of service. So basically flooding that 5.9 gigahertz band with unnecessary traffic can result in large packet losses and large latency seen by the devices that are sending out messages between the vehicles and infrastructure. Once again, interfering signals in the same or adjacent bands can also heavily degrade performance. Cybele and other forms of integrity attacks can greatly undermine the reliability of this system, with a Cybele attack basically being a bad actor creating sort of many fake identities to become a trusted user in the network, and then once the once they're a trusted user in the network, they can basically manipulate anything they want to basically say there's a bunch of traffic in this area, or direct vehicles to a certain area that they want to. So greatly undermining reliability of the system. Next, moving into the healthcare sector. This is focused on the Internet of Medical Things, which is a collection of medical devices and applications that are being used by healthcare providers. And these devices are being used to improve patient treatments, their experiences, reduce the number of errors that providers are making, manage and handle the drugs that are being used during operations, and lower costs to the hospitals. Some of the main sort of risks with this network of devices, they're primarily handling and exchanging sensitive patient data, such as their personal identifiable information. And unfortunately, many of these sensors do not utilize built-in encryption due to limited computing resources. And additionally, these devices are just physical hardware, so any attacker could plug into these devices if they wanted and install a set of malware that would allow them to remotely control the device. There have been examples of ransomware attacks that start on one device and then spread to others in the network. And additionally, these devices are broadcasting the GPS coordinates of patients in some cases. Um, there have been additionally serious security vulnerabilities reported with drug pump systems, and the attackers could easily exploit the system's firmware and provide any desired dose to patients that they please. Now moving to drones, a similar concept, the Internet of Drones to the Internet of Medical Things in the previous slide. These connected drones can perform a variety of tasks such as search and rescue, infrastructure monitoring, agricultural assistance, disaster management, and much more. Naturally, with a drone, sort of the most important problem that it needs to constantly solve is localization and position estimation. And so, like the devices that I described in the intelligent transportation system slides, these are once again sensitive to GPS spoofing and jamming attacks, and kind of a symptom of the size of drones, since they are relatively small and trying to minimize weight. They are typically characterized by low computational resources, a small amount of memory, and low energy consumption. And what this means is that sort of traditional cybersecurity methods and techniques may not be available to drones or applicable just because of the amount of computational resources they would require. So additionally, various forms of malicious software have been successful in deactivating the drone's communication with their remote navigation controllers. And then, once again, surprisingly, sort of unsecured communication channels between the drone and its navigation controller has allowed eavesdroppers to listen in and basically gain access to this network if they were able to decode some of the information there. Okay, moving on to ethical theory. The ethical theory that I selected for this analysis was Aristotle's virtue ethics. Virtue ethics concentrates on the development of moral character traits or virtues rather than an abstract set of rules. This differs from other ethical theories like deontology, which put the primary focus on how morally good an action is based on strictly applying a set of moral principles. Aristotle acknowledges the importance of context when evaluating situations and behaviors. He describes virtue as a mean between the extremes. Essentially, what this means is that virtues are depictions of kind of moderation between two opposing vices. They are developed through habit and practice, and kind of central to his theory is the concept of eudaimonia, often translated as happiness or flourishing. And what this is it's not achieved through the pursuit of pleasure or avoidance of pain, like the utilitarianism framework, but by living in accordance with reason and fulfilling one's potential as a human being. So now for the application of a couple of Aristotle's virtues. The first one is prudence, and prudence is basically the practical wisdom that is focused on applying moral principles in situations to be able to determine the best action. One of the key components of it is being able to understand not only what's good for the individual, but for the society as a whole, and being able to have the foresight to understand not only short-term impacts of something, but also the long-term impacts. So when that's applied to cybersecurity and hacking and robotics, there's a couple things that I want to focus on. So comprehensive risk assessments need to be developed to understand the likelihood and impact of potential cyber attacks. You can see that risk assessment matrix on the right there, giving you an example of comparing the severity of a risk versus its likelihood. There needs to be an emphasis on robust security protocols to protect against threats from all available attack surfaces. These protocols need to be constantly updated and maintained. I think that's a key part here. Technology is changing so fast these days that it needs to be continual effort to understand security threats and then respond to them. There needs to be easy ways to securely update devices in the field. We need to understand the potential for technology's misuse and the large-scale implications of an attack. And this needs to be done early in the design process so that you're not reacting once the technology has been deployed. And then finally, engaging with a wide range of stakeholders to understand how they plan on using the technology, understand their use cases and the ways that I think that will be able to paint a picture of additionally ways that the technology could be misused or some of the additional vulnerabilities that are associated with it. Now to the virtue of courage. This is the mean between the two extremes of kind of foolhardiness and cowardice. I like to think of it as kind of the way that the virtue that would allow an individual to be kind of presented with a difficult or new scary situation and approach it with an appropriate amount of confidence. So when applying that to ethical concerns, developers and company executives need to be able to openly discuss the concerns and fears that their technology could potentially be causing to the public and not pretend that they don't exist. You need to present these measures and present the measures that have been taken to mitigate these concerns. So this kind of goes kind of hand in hand with that prudence virtue that I was describing, is having the foresight to develop these measures to mitigate concerns and then present them to the public and be able to receive feedback. Like I mentioned before, being able to consider long-term impacts of the technology and not solely focusing on the financials. Um, and then being, willing to understand that this could result in delaying the release of the technology or even altering the product in certain ways if risks are too high. I think that uh, engineers, executives, marketers, whoever should be advocating for actual policy that promotes the responsible development and deployment of technology. And some of these policies would be, um, national or worldwide security standards and practices that all companies should be able to follow. And then lastly, when failures in security occur, and it seems like in this day and age that happens quite frequently. Take quick action and have the courage to take responsibility for it and do that in public. Be transparent about the problem and how it is being addressed. The last virtue that I applied to this situation is justice. And justice aims to restore balance or equality that has been disrupted by wrongful conduct. Some examples of that would be fraud, theft, or some other form of harm. And when we're applying this to cybersecurity and hacking, I think that the first thing is ensuring that cybersecurity measures are accessible to all users, not just those who can afford sort of premium protections. Kind of specifically thinking about the Internet of Medical Things and patients who are kind of in that vulnerable spot of these devices becoming more and more a part of healthcare and them seemingly being pretty unsecured along with exchanging sensitive information. These patients deserve to have these devices protect them and their sensitive information. Um, then when cyber attacks do occur, um, justice needs to be that there should be mechanisms to rectify the harm done to individuals or organizations. And this could kind of come in many different forms, whether it's compensations, restoration of lost data or services, and efforts to prevent future breaches. Um, so kind of once again going hand in hand with that courage virtue of being able to openly and publicly say that a mistake was made, and then justice kind of allows for uh, that rectification of that wrong. And then as new technologies emerge, there's going to be a need for new laws and standards that will address the new challenges that these technologies are presenting. And these laws need to aim to protect individuals and the common good, ensuring equitable access to technology's benefits and protection from its risks for, once again, not only those who can afford premium protections, but for all users. And then here are the references. That'll be it. Thank you.